first time. I am live, allegedly. So awesome. So let's talk about stuff and things. And we have consulting, virtualization, FreeNAS storage. I got fun stuff to play with, and we're going to play with it here on the live stream. I was actually finished a few minutes early. I was on the TechNado podcast. So there'll be some links I'll be tweeting out for that. What else do I got here? Actually, I want to see something. Ooh, Ponagachi. That's it. This is going to be exciting. I'll drag my Twitter over here real quick. This is going to be for an upcoming video, but let's go here. And what did I tweet? This, the Ponagachi. We're going to be talking about this pretty soon. My staff have been diligently working on this thing. It's a whole fun little project. If you follow me on Twitter, you can get the details. But basically, it's a Wi-Fi project that right here. Let's go on GitHub. We'll talk about it a little bit while we're getting started and everything else. Ponagachi is an AI that learns from your Wi-Fi environment and instruments ButterCap in order to maximize WPA key material and any form of handshake that is crackable. So it's been interesting. Cool. We got one new handshake. So it makes friends and does some wire stuff. That's, like I said, a whole different video we're going to be doing in the future. So I'm excited about that. That's we got it finally up and running. Well, I shouldn't say we, Kyle did. So that's awesome. Fireball Digital, hello from Michigan. Awesome. I had the comments pulled up. Actually, what new message do we have in the forums? I'll look at this one in a little bit, but about an hour ago. All right. I try to stay up with all the forum stuff, and that's part of why I actually, one of the things I'm going to do is probably reply to some more people with this. What case you're using? 3D printed. Printed. There we go. Woohoo. No machine, NX server. So I try to reply to all the comments, and I try to interact with people as much as I can, but there comes a point where it becomes consulting. I bring this up because it's happening more and more where people seemingly, they think it's okay just to email me and say, but I only have a few questions. I only want to talk on the phone for you a little bit. And then I have to charge people. This is what I do for a living. And that's where people keep getting confused because they can't believe I would charge for my time. And they want a quote first, and I'm like, no, even the planning, because you don't know what you want, is also part of charging for my time. It's been a difficult thing to get through to some people, and I am absolutely nice about as possible. There's a reason we have a process, a contact form, a booking form that doesn't let you book a time until we get paid up front, because I can't charge you on the back end and chase you around for it. And it's been a back and forth situation with a lot of people that has been going on and on. I've some people like, I wouldn't pay you. I just want you to tell me what to buy. And I'm like, and I do say thank you for people who use my affiliate links. But the other side of it is I can't consult with you for an entire project for you to buy an access point. Someone called the other day, was mad because we wouldn't talk him through all the options of buying an access point off our affiliate links. We're like, don't take it the wrong way. I appreciate it, but we only make like 2% on that. So I can't spend 20 minutes, 30 minutes on the phone with each person talking them through their Amazon purchase of the cheapest thing. So it's like, yeah. So it's one of those things, and it came up again today. That's why I bring it up, where someone was just really trying to email back and forth like they wanted me to quote them, and they didn't know what they wanted. They wanted me to help them choose a firewall. I'm like, well, how much to set up each one? I'm like, well, which one do you want? Well, I need you to coach me through each one. And I'm like, no, I can't coach you through the firewall. Then you want me to walk them through loading it, like, I guess on the phone. And I'm like, it's hourly. Well, how long do you think it'll take? I don't know. How good are you? Well, I don't know what I'm doing. I said, well, then it's probably going to take a long time. There's not a way for me to quote that. That's why for those people, I'm going to throw an hourly rate of $200 an hour on it, and we're going to play it by ear. There's no way for me to know. When it's a project and it's clear and concise, I can give an actual price on it, and that's much easier. But when it's a bit of randomness of, I need you to walk me through something I have no idea how to do, and I'm not even sure which thing I want to do, well, there's not really a way for me to give you a concise thing on there. Also, a lot of people who ask questions here. That's why I have this brought up. I started replying with like, just go to the forums. Like, it's really hard to interact, and I've said this many times before. One person decided to randomly go around until they got caught up in the spam, to which I let the spam system take care of them. They posted the same question on like a dozen different videos, and it was like, hey, you reply to my email type weirdness. I don't understand. Like, I have forums if you want to have a public discussion. So people confuse me sometimes. I'm just throwing it out there. I am very responsive, but I have links to everything to where you can get a hold of me, that we can use these forums. I just want to bring it up real quick, and that's some of the consulting stuff that we do that's there. Now, the reason I spend so much time on the forums is I like that the forums are now becoming indexed within the search results, because you may be asking the same question that someone else. So if you were to try to type something in, and we'll talk about PF Sense, and the system can realize like, hey, that's a discussion topic that's been done before, and it can help you search this, and it can help find it. So actually, I should probably start the topic on firewalls. But you can now search this and then find all kinds of answers, like how to set up PF Sense with a Cisco Layer 3 switch. That's why I push so many people towards this, is now everyone can learn from the answer, versus if I email you back and forth, only I spend time doing it. You may get some knowledge of it, but it's not shared with the greater public that could really probably use the knowledge and have the same questions. So let's see. We have here, hello again, Oregon, awesome. Yeah, register myself as a charity. Not gonna happen. It's more complicated than that. Recently bought a new 4K TV. Looks good. Appreciate the things you do and awesome stuff. ZFS Butterfly Chef. I need to choose a file system. Pick a winner, Lawrence. Start using ZFS. There's my answer. So definitely ZFS is awesome. We're going to talk about ZFS today too. That's actually going to be one of the things that's up for the discussion today. ZFS in all of its glory. Cool. I just told someone they're a spammer. They actually replied and said, oh, I'll stop spamming you. They keep filling out my contact form, trying to get me to do something. I'm like, I'm not ignoring you. I have no interest in booking your banquet center. It's like, hey, wouldn't you like to have a party at our banquet center? No, I wouldn't. You've sent 5 emails and filled out my contact form 5 times. I banned you, just letting you know, if you're doing this everywhere, you're going to get on spam lists all over the place. So I had to send that to someone. Fun times. Let's see. Trinidad, awesome. Do I prefer NFT or IP tables? I like PF. So third option. So what are we going to do here? Let's bring up all the windows I was going to talk about, and we'll probably start with this one. Sorry. Something in my throat there. So here's one of the things that comes up a whole lot. And let's open up. Actually, is it open over here? Oh, cool. We can drag this whole window over here. I don't need this window, this window. No. We can actually close all those and drag this one over. Woohoo! Got a FreeNAS Mini XL set up with 4 SSDs in it. Also, we can talk about storage and fun stuff like that. So, hey, thanks, Mike Morabito. I'm sorry if I'm saying your name wrong, Morabito. I don't know the format of your stream, so sorry if this is out of place. What are your thoughts on vanilla free BSD with ZFS, Gluster for HA storage? Not a Gluster expert, so my thoughts are ZFS is awesome. I've not set up Gluster, so it's not one of my fields of expertise. So I'm all about talking about storage, but I'm not a Gluster person, so I can't truly answer that. Oregon. Yeah, Oregon is how I call it. But yeah, Mike, I'm not so what I do know is some of my friends that are more into storage than I am, they seem to really like Ceph, C-E-P-H. But once again, I'm just not an expert to say Ceph versus Gluster even, versus Gluster FS. I know they're like like it says here, they're systems for managing distributed storage, but it's just not something I've done a ton of work or research on. So, because the majority of us is just use their backends for virtual machine storage and things like that. So it's not as much distributed. But my friends who have designed cloud infrastructure, I know they built on both of these technologies. Different friends have built larger cloud infrastructures based on these. So I can't unfortunately give you a really good. Look, there's even a third option, Ceph versus Gluster versus ZFS. So it goes beyond the scale of the big data that I end up dealing with. So let's see, what do we have here? Why would I try Pi-hole on a 4? Pi-hole works on a slow-end Raspberry Pi because it's just simply it doesn't take much to run DNS, and I did a video on it forever ago, but honestly, like my day-to-day use, I have pfSense at home and at here, therefore I run PF Blocker, which therefore is a Pi-hole by itself, so I don't need a separate device. That's my solution for it. So you can run it on whatever if you want to waste a Raspberry Pi 4, but the reality is you're not really wasting if you buy the base Raspberry Pi 4 because, well, it's inexpensive. So it will certainly work with should. I don't know any reason it wouldn't. So you shouldn't have a problem with it working as a Pi-hole. What else we got here? LastPass for password management. How do you deal with strong password cookies automatically logging in your browser? I don't know. I deal with it by letting it do it. I guess I don't understand that as a question. Does Invoice Ninja allow project level budget tracking? Kind of, probably not in depth. Play with the demo and see if you like the way they do it. Hey, thank you, Bill Daughtery. Awesome. Dory? D-A-U. I am horrible about saying people's last names. Sorry, that is if I got your name wrong, but thank you very much for the donation, and Mike as well. So all these donations make me excited. It keeps this channel going and keeps me going for all this. So what are my thoughts on Brave browser giving me back coins? No opinion. Sounds interesting. No opinion on it. You know, I drive my wife nuts with I don't have an opinion on that, but I say that a lot because some things I don't have an opinion on. I consider it my superpower. People ask how you stay focused. I'm like, because I don't have an opinion on a lot of things. They're just things that happened, and some people get real excited about things that happened, and I'm always like, it happened. I don't know. I don't really, I don't always have an answer for some of those things because I've never really put much research into it because it doesn't. You know, unless I'm making money off of it or unless I'm trying to make money out of it, there's nothing about the Brave browser that made me go, wow, I need that. I think it's a neat concept. I don't know if it's really that exciting. You do all the configuration for net data, which I have pulled up here. You do it all in the back end, not the front end. There's an XML or a YAML file. I can't remember exactly what is on the back end of this, but yes, there's a file on the back end that gives you the settings so you can do things in here. So it's maybe I'll do another, since they came out with a new version of NetData, it's definitely improved a lot over time. So it's definitely really cool software. I really love that it's integrated into FreeNAS, which we're using here. So definitely like that. CCNA, is it worth it? I can't answer that question subjectively because I do not have a CCNA. Can I run UNMS and a one computer as a VM? I have a Core 2. So you can virtualize pfSense, which I don't recommend, but people want to do it, and it works. You can. I have virtualized it. I use it in my lab, but I don't use a virtualized pfSense in my production. It can be done. You have to have a computer powerful enough to do it. I prefer to run it on real hardware, but yes, you can virtualize it and therefore run other things on that one physical machine. I think I have a video about doing that as well. So, yeah, the whole virtualizing is, I get it, but the problem is when you virtualize, if you have to do things like restart your server, you also take down your internet, and that can be aggravating, especially if you're having a problem like me and you're building a lab and you have some problem you may have created and you may need to Google search to find said answer to problem, but you're like, oh, I have a virtualized pfSense and I broke my virtual stack, therefore I have no internet now until I figure out the problem without internet. So you could see it being a problem. Now, where that works really well, if you have a whole HA cluster enterprise where you have a HA system in complete failover and you want your firewall to be part of that failover and you've done all the proper redundancies, well, there's pretty cool because now you can upgrade things, you can do all the fancy features you get with virtualization, and your internet doesn't go down because you've kept it all in one physical one physical VM, or not a physical VM, but one VM that you can pass between the multiple physical servers for HA. So yes, I like it when you do it in that instance, and it's fun from a lab standpoint because that's why all my lab ones are virtual because, well, it's just way easier to do. But you know, honestly, you can buy an SG3100 so cheap, you're a few $100s and have full gig connection, or if you're just a home user and you don't have faster than a 500 meg connection, even the SG1100 works. So something to think about. It's so inexpensive to build, and not to mention you can build it on your own commodity hardware for pretty cheap. That's a whole nother topic. Let's see. Very cheap firewall for 23 years Office. And one for SG3100, like I talk about that one all the time, is pretty powerful, and we have a lot of small offices using it. It's kind of a good, easy, simple go-to system. Do I have a favorite tech channel besides me? I don't know. I read way more than I watch. So I don't watch as many YouTube videos. That's a fair question, though. I'm trying to think. I would have to look at my personal subscriptions, and let me look because I can give a real honest answer. And I have to look here because I don't feel I have to switch accounts, and it would break the live stream. What tech channels do I follow? I like Marquez Brownlee is awesome, so I definitely follow him. Let me think. Who else do I follow that's tech? Jerry Rig Everything's pretty cool. I like watching him take things apart. He's pretty entertaining. AVE blog, I like him. A lot of it's random. I don't have that many subscriptions of tech people, so that's my honest answer. I don't follow a lot of tech people. I'm more the person who participates in forums and things like that. That's where I get it. Oh, Hack5, of course. Hack5's awesome. They do some great stuff. Oh, Epos Vox. I like not all his videos, but some of them are really interesting. So he's definitely good. That was it. That's all my tech stuff. Never use Fusion PBX. I like free PBX. It's well supported, well documented. It works well. How do you manage pfSense remotely? I've gone over that in a video, I think called pfSense Remote Management. Well, that's my son. I'm gonna message him. I am in a live stream. There we go. So yeah, I've talked about remote management. You can do it through proxy change. You can do it through filtered WAN ports, and you can do it through VPN. So those are all options. Or frequently we have access inside the client networks, so that's another thing we do. YouTube gives ideas on what to go read. Yeah, that's probably fair enough. What about Linux channels? What Linux channels? I don't know. I don't really follow. Level 1 Techs. They have some really good content. So Level 1 Techs, I'll list them up there as someone. I occasionally watch some of their Linux content. He's really talented. Goes quite in depth on stuff. Let's see. You should plug Darknet Diaries more. Yeah, Darknet Diaries is awesome as far as podcasts. So I definitely love Darknet Diaries. Yeah, I talk about using the FreeNAS Mini Plus for transcoding Plex. That's definitely a good system for that. I'm not an expert at transcoding Plex and what specs, but you spend any time in a forum, they'll tell you what specs you are required to transcode different streams. I'm not an expert on that. I don't really watch much on Plex. I have been a Linux admin for, let me think. 1998 was my first time I had to admin Linux. I was loading it before then, but when I actually had to, 98 or 99 was when I first started running mail servers in Linux. So, nope, no Discord server, no plans on a Discord server. I don't got time for that. I don't do a lot of real-time communications very well. And Best Online Training, IT Pro TV. Check them out. They're a sponsor of the channel. We really like them. Their system is good. Yeah, turned 21 years of using Linux. I know, it's been a long time. I got some gray hairs to prove it. Definitely a thing. My son's messaging. He's having computer problems. So I'm like, I'll deal when I get home. I'm off the channel. There you go. Let's see. All right, back to some of the stuff we were talking about. So this right here, before we got started, self-taught, be a Linux admin, which I do to first give myself the best chance to get into workforce. Figure out, you got to niche down on what you want to do for getting a workforce. So you have to figure out what the job is you want. You have to learn. You pick a discipline. Are you going to be a sysadmin? Are you going to be a DevOps? Are you going to be a person who orchestrates cloud infrastructure? You got to narrow down. I can't answer like, what do you want? Because I don't know what you want. That's always a really tough one. How do I get started in tech? You have to pick a passion for it. For me, it's like all of these things are just fascinating to do, setting up systems and engineering. So it's hard to say where to start because I don't know what you want. That would be the answer. Figure out all the different things and figure out which one you like. Maybe you like programming. Maybe you hate programming. Maybe you like setting up storage servers. So yes. I currently work for computer information technology and security administration. Should I get anything else? I don't know. Yeah, virtualization is awesome. They have certifications for it because a lot of places require certs. I have 0 certs, and because I am self-employed, I don't need certs. So I know the market needs them, so I'm not saying that they're bad. I'm saying I don't need them. So, do I travel the West Coast for work? Yeah, if you're buying, I'm flying. So yeah. I will travel out wherever the work is. I don't travel much for work. I'm traveling to Florida for work soon, but that's mostly based on my travel for work is based on if someone's willing to pay. If you're willing to buy me the plane ticket and pay for all my time, absolutely. So that's how I look at it. There's a price tag attached to it. That's all. So this is 4 SSDs, and we have SCSI 1, which is an iSCSI connection. And we have a Zen Lab SSD right here, which is, both of these here are data sets, or I'm sorry, not data set. One's a ZVol, one's a data set, but they're both storage pools for my virtualization. Now, people complain, I think this is a misunderstanding of how you should plan your storage, is the first part. People say, oh man, I can't use XCP-ng because it doesn't support more than 2 terabytes for each one of the disks. Then that's just not enough for my storage needs. You should absolutely not be storing it that way. You should not have all of your storage stored in a VM. That's not the way to do it. And I'm going to throw up some examples here as to why. When you're building the VMs, virtual machines should be the OS systems and the virtual machines. Now, if there's not a lot of storage involved, everything can be in there, but a lot of times there is storage involved. And you want the storage to be fast. And when you add the layers that a virtual machine adds to it, especially the hard drive layer, by abstracting that one more layer from the hardware, you introduce a lot of overhead. I get the advantages of being able to snapshot it and everything else, and that's wonderful, but those advantages turn into the disadvantages when it comes to performance and speed. And this is why the 2 terabyte limit to me is like, that's not even a big deal. None of our systems are running that big. Even the Windows ones aren't that big because they don't need to be. Once you start looking at it from a different perspective, that perspective is you want to take the storage and present it as directly to the users as possible. For example, if we had a Windows server with a domain controller and that's running as a virtual machine, but then we have 10 terabytes of storage that we have for all of the client files. Well, there's 2 ways to do that. One, you could present an iSCSI extent to the Windows Server 2016 VM, and by doing that, you've now connected the files directly to the server, and they're going to be nice and fast. Option B, you tie Active Directory, so you have all the full permissions managed by the Windows server, and it just becomes a normal file share that the users access directly. They're not accessing the VM, so all the bandwidth is going directly between the users and the FreeNAS box. Therefore, you can use ZFS snapshots to be able to do the snapshots there. And because everything's being handled at the file level, you're going to get the absolute best performance. And we've had to unwind people who set up storage servers and they just stuck everything in the VM, and they can't believe, even with these really fast servers, they have how poor the performance is. Yes, that is what ends up happening when you stick everything in one giant VM, and it's kind of a pain in the butt. It's also a pain when you want to migrate the server, because let's say we want to migrate to new hardware. Well, if we have to migrate this massive file, now it's that much harder to migrate, backup, or restore, versus when you separate these 2 things into separate entities, it becomes much more manageable, especially when we do have clients that have 3 terabytes, 4 terabytes of data. If that's all in one VM, I have to move a 3 terabyte virtual hard drive file around. Obviously, that's just not going to make sense. So let's talk about that. So do I need certs for my employees? Not required. They do not have to be certified to work for me. Not on my requirement list. So is NFS the preferred path? Oh, that's a good question. We'll start there. So we have both set up. So we have a NFS server, and where you got here? Oh, that's the Windows one. I need the Debian NFS. So there we go. We're going to fire up the FreeNAS Mini XL Plus. This is the Debian Lab. This one is NFS. And the other one running is this one here. This one's on the iSCSI. So we're going to, they're the same VM. All they did was clone it over to the other side. So there's not anything too special here. We're going to go ahead and pull this up. All right, see if it's booted yet. 158. Which one is this? Make sure I got the, whoops. So this is 158, so this one should be 147, and it is. All right. You need to do like the boxing announcements. In this corner, we have the Debian FreeNAS Mini XL Plus NFS. And in this corner, we have the Debian FreeNAS Mini XL Plus running iSCSI. So, someone says, VMware had a lot of discussion about multipathing on their training programs for this topic. Yes, that is true. Question regarding you for iSCSI eval, so just mapping in VM. So yeah, it's a worthy topic. Like I said, I get it, and there may be times when I'm speaking from the basis of what I have, but if you have a massively powerful storage SAN, then you want to put everything in there and you have something that can handle the back end. Maybe that is a good way to do it. But I'm talking about how I normally would see it set up maybe in an office. And this is going to be different, of course, if you're building it in AWS or something else. You now have whole different abstraction layers. So right now we actually have, and we're going to remove it. Let's go here. And this is going to break, so I'll shut that down. We actually have this with a log drive, and we're going to start out by not having it. So we're going to go here to status. And we're going to get rid of the log. So we're going to get rid of it, so we'll start without it. So we're remove it. By the way, if you didn't know, you can remove cache and ZIL at this while the machine's running and the virtual machines are attached to it. They can be removed, and that is not detrimental to the system. Actually, make my head smaller. Someone really wants to see my head. There we go. Anyways, so you can remove these dynamically and add them back. So all I do is remove them. We'll leave the cache, but you're going to see it's not doing too much. And yes, this is TMUX right here that's splitting the windows. So here's the 4 SSDs. Here's the 4 drives in a RAID Z 1 configuration. And here is the cache drive, which, by the way, you can see isn't doing too much right now. And let's go over to the pool itself. And we're going to go here. And this is an NFS share right here. So this NFS share, we're going to edit the options. We're going to change it to disabled sync save. By the way, you can turn sync on and off. And we'll start with this right here. And this is the discussion topic about how NFS versus iSCSI works. But there's a lot to the story here. And I'm going to do a whole video in more depth in this. So you guys are getting a preview of how I even put together some of my videos. So NFS by default will implement sync rights as requested, and this is talking about ESXi, but insert whatever hypervisor you're using. If it's attached with NFS, these are true statements. Some people think that sync disabled NFS share to gain speed. This causes async writes to your VM data, and yes, it's very, very fast. However, sync rates off, you're risking both ZFS metadata and the integrity of the VM if there's a failure. So this is really awesome in terms of speed, and really less awesome in terms of the way you could potentially lose data. So we're now setting this up with NFS, and we're going to show you what happens with NFS when you have it not synced. So we're going to do some raw speed testing here. So speed test, and then we'll go here and do speed test. So you're probably thinking, wow, 741 megs a second versus 988 megs a second. This is definitely the winner using this right here. Now, please note we don't have a ZIL drive. We just have the cache. And if we even run these repetitively, the cache barely gets a couple megs in the cache, not a big deal. But the cache is SSD, and these are all SSD. So we have these really nice, fast numbers. Now, we ran at the same time, so we both dropped a little bit on the numbers, but you get the idea. Now, I also have Phoronix on here. And we'll run a more intense benchmark. So 1, 1, 1. We're just, whoops. 1, 1, 1. No. So now we're going to run a benchmark on this. We're going to show the difference. We're going to get to the snapshots. That's where things are going to get even weirder, is what happens when you start snapshotting all this stuff. So here's the runs. And by the way, sync is turned off, so you can see all the reading and writing happening up here. These are, we're actually watching the drives. And by the way, just because someone's going to ask, all I'm running for the stats here is zpool iostat-v, the name of the tank, and 1 for updating 1 second. So that's all the command is that runs that. So sorry, we got about 500 megs on that right here. Let's run the same test over here. This is the Phoronix test suite for those of you who aren't familiar with it. So we're getting about a 500 meg. Now this is a write test, and it's going to be more intense than all the speed tests. What the speed test was, and we'll pull it up in a second here after this runs. What the speed test does is just quickly write a file out. So once again, we got an average of 500. And we got an average of 443. So we're actually a little bit closer in speed, more realistic. There's also lies, damn lies, and benchmarks. Running benchmarks does not necessarily give you the true understanding, but we get some baselines for this. And let me talk about that speed test file. All the speed test did was create a file that was this big and delete it. So it created a roughly 2 gig file and deletes it. So it's all that really matters. So let's see. This is all RAID on top of SSDs. Everything here is SSDs. So speed test again one more time. 963. And we sped up this time, it's 804. So you can see what's going on. But this is with that dangerous potential 5-second loss if there was a failure of the drive, like we said here. Every 5 seconds, it writes a commit. And this is where we have a slog drive involved. So if we turn on, we've got them turned off right now for speed. We wanted it blazing fast at the risk of doing it. So now we're going to go over here to the Zen Lab SSD test here. And we're going to edit options, sync always, save. So now we're saying absolutely don't let asynchronous writing happen, which means excellent integrity. But asynchronous writing on SSDs, we're going to show what happens with asynchronous writing with SSDs. So we had 963, right? Speed test, 963 megs. What do you think we're going to get when we turn on asynchronous writing? Here's it all writing, but it's actually committing every minor change of the VMDK file. So now it is really, really intense because let's look, it's still not complete doing. We see the writes happening. We went all the way from 963 to 103 just by telling it to do full synchronous writes. By the way, over here, the writes are synchronous anyways. And the reason it's pausing right now after it did it, to delete the file, has synchronous writes that it has to catch up on for the writing of it. So look how long it took to delete the file. So first it took that long to create the file and then that long to delete the file. This is what happens when you have a synchronous writes. Your data integrity is really high. Your performance is pathetic, which is actually the whole title of this article was Sync Writes, Why My ES6 NFS is so slow. Matter of fact, what I'm going to do, just because I'll mention it, I'll throw it in the notes here so you guys can follow along if you want to dig into that. So now let's extend this, and we're going to go here, extend, and we're going to add the slog drive to it. So right here's a available disk, and we want to add it as a log drive. So we just go hit this, then we hit extend. So it's the only change we're going to make. We're just going to add this extra zero intention ZFS intention log as a write pool. So it's been added, and here it is right here. So there's that drive we just added, and now we run the same speed test. And you can see it has 333, 327, and we're up to 428 megs a second. So we went from 963 asynchronous, but potential loss of integrity, fully synchronous with 103, pathetic on SSDs, that's not really manageable. But then we come down here to 428 when we add this. Now, this is just, these are all SSDs, they're roughly the same speed. The way you would get more enhancement out of this, and there's going to be a follow-up video when I get more in depth, is you'd want to do something like an NVMe as your slog. There, you would have a write performance. The idea is the zero intention log should be faster than the other drives that it's sitting in front of. It's not caching, it's the intent log. There's a very distinct difference there between the intent log and caching. But let's go back over here. We're still rocking along at the same speed. But now that we've brought this down to closer to 500, yeah, exactly. So like someone pointed out, 900 megs is already like 7.6, so you're already, your 10 gigs is almost full and topped out. That's correct. Oh, and I didn't mention it, but I'll run the test real quick. Here's the FreeNAS. Here's the server. It's connected at 10 gig for those that are wondering. So there is a 10 gig connection between them. I probably should have clarified that in the beginning, but yes, that is good point. Good point, Rob. So now let's talk about what's really going on. So this is all cool for benchmarks and lies and things like that, but that we didn't build a VM system just to run 2 boxes on and put 1 on each storage. That's not why you built this. You built this because you want to run many things on here. Matter of fact, one of the things we're going to do here, we're going to go here and create a snapshot. And then we're going to go here and we'll create a snapshot here. Now what happens is when you create snapshots, you just gave another task for the hypervisor to do it. Now it has to keep track of those snapshots at the file system level. So now we'll run this. So we went from 598. And what happened is we created this 2 gig file on this VM. It had to track the difference between the 2 gigs that we keep creating and the snapshot, because a snapshot is a snapshot in time, so we should be able to roll back to it. Same thing here. But what's happened with the iSCSI is it's handling it better. I already know this predictively because, well, I've already done some testing. Look at how little we lost on the iSCSI versus how much we lost on the NFS extents. And let's go ahead and make a mess. So new snapshot. Let's do a few of them. We have to track more snapshots. So we have a few more snapshots we tracked. Now what's going to happen to the speed test? We're tracking different points in time. The more you have to track the differentials between these, you can lose more. There's not going to be too much difference because we snapshot them sequentially, but you get the idea. You will lose speed as you create snapshots in there. This is less on the iSCSI side. The other thing that's important to know, and let's go there real quick. Mount. Here's all the files, and let's actually list them like this. Here's the ones that are happening right now that we're doing. And you can see that there's small differentials between them. But even after I delete this, I thought this was kind of interesting. Even after you delete these, so we're going to purge them real quick and purge these snapshots. A couple of them are still there. Why are they still there? They haven't had time to coalesce. So let's go ahead and try this again. Even though they're gone, did we get the performance difference yet? Probably not. I'm willing to bet they haven't coalesced. We're still stuck here. So even though those snapshots don't exist until they coalesce. But on the iSCSI side, let's go over here. Go to iSCSI. They may coalesce a little bit faster, but it's still kind of interesting. So now it went back up. Let's see if this one does. It takes idle time for them to coalesce. These are all things you have to think about. Okay, now we're back up in the 400s. Does the iSCSI need more drivers installed than on the client side? Not at all. When you're doing the iSCSI, it's built into Windows since Windows 7 or older. I know Windows 7 had it built in, Windows 10 for sure. Windows servers had it built in for a long time. iSCSI's been around for a while. It's far from a new service. But let's also do this. So we're just talking about all these things, and let's get some Windows boxes going. So here's a Windows box on the iSCSI and a Windows box on the NFS. So now we have more things going on. So while Windows is booting, and then we do this, and we do this. So we just kicked off a whole lot, and let's see how these things are handling it. Actually, let's do the Pharonics test. 1, 1, 1. No. 1, 1, 1. No. So now Windows is booting. These are running concurrent tests, and we're overloading the storage server. Let's see which one's handled. We kicked them off roughly at the same time. This is not perfect science here. Pull up stats. And we can see we're using all the drives. We're filling the cache up, the zero intention log up. We're filling the cache up. This is getting some variations. Now let's look at the important numbers here. Actually, I can split the windows like this. So if we go here, and then we're going to go to storages. Do this one here. Oh, fun window splitting, right? Storage, and we want the NFS here. Actually, we need not the NFS one. I need the other one here. So let's go back. Where's the SCSI one? Dozer SCSI. There we go. Stats. Now we can see what's going on the back end for each of these. So we've split this FreeNAS Mini XL Plus, by the way, is capable of about 20,000 IOPS. But because we're running these concurrently on the same disk set, we're only getting about 10,000 IOPS peak right here. Well, a little less than 10,000, like maybe 16,000. So 8.6 times 2, 17,000 IOPS between each one. And we're getting about 300 megs a second here, and we're getting about 287 megs a second here on the SCSI side. I have SCSI in both? Yeah, I did. Now I don't. This one, oh wait, I do. You are right. I should pay more attention. The microphone is in my way. That's what I'll blame. There we go. That's why they look the same. There we go. Now I see the difference. Perfect. So here we have And the same thing, we're still splitting them. Answer's still the same. As you can tell, I may have already done some of these tests before to know some of the answers, so I can talk to the numbers. But what I thought was interesting is the latency on NFS. This is your wait times. So your I/O wait time and your latencies, we're up above 30%, and we're under 20% here. We have a 4 millisecond latency when you're running it on this here versus right there, we're sitting at 7 milliseconds. So your wait time for I/O is actually a lot less. Let's see how our tests are running. Looks like they're done. And the iSCSI is beating it out. So now we're more real world by the fact that we've got multiple VMs running. Let's build more VMs. So let's go ahead and make more noise, so to speak. We're going to make a snapshot of the Windows box here. Then we'll go back to the NFS one. We'll make a snapshot of this one here. So now we're creating a lot more I/O activity. Matter of fact, hi Windows, let's go ahead and reboot, because that'll cause Windows to do more stuff. So there's the NFS one rebooting. That's, we'll reboot this one now. There we go. That'll create some more differentials between them. We'll go back to this and see what's going on here. And we see, okay, it's doing some more reading and writing. Windows doing its thing. Let's kick these off. And this time we're going to run option 4.1.1 for all tests. 4.1.1. All right, so now it's just going to be intense. Yeah, this is all landing on exactly. Oh yes, XCP-ng guest tools. Kind of the way you do it. I have a video on this. Just turn this on, and it will load all the drivers. Windows has drivers built in for Citrix. It uses the Citrix drivers. So as long as you have this turned on, it'll have the hardware built in for that. So this is still rebooting. And let's see who's the winner now. Now we have pushed the I/O latency, and they're both doing the same things roughly at the same time. We've kicked them off within a few seconds of each other. We're seeing, what, 15 millisecond latency now? I/O wait times of 45%. But here we are on the SCSI side, where we're only seeing half that, 6 millisecond, well, less than half, and only 30%. And they're both booting. So we're getting better overall IOP performance. Matter of fact, this one looks like it's further ahead in the test than this one is too. This one's already completed a test, and this one's still running. So iSCSI is really becoming the winner right here. Now, let's do this. What happened was when you add and remove, just so you know, I'm going to stop and start this. Net data. We're going to take a look at what's going on with net data. With net data, if you leave it running when you add and remove the cache drive, net data seems to lock up. So all I do is start and stop it. All it does is it gets confused by that. We are beating up the CPU on this. And let's look at, what do we have here? You can look at different things. For example, let's look at the network interfaces. There they are, receiving, pushing a lot of data. Here's a ZFS system. I think, does it let me list each one? Hits and misses, operations. You know, I thought it broke down. I guess I'll probably take some customization to actually add more charts. Can I add an iSCSI chart to it? Nah, not here anyways. But it's spreading the writes across all the disks. It is doing that. And does this have a way? See, it doesn't have anything that really breaks down other than what I'm showing you here. They're all, trust me, they're both on the same server. They're both running on the same free. Matter of fact, they're running on the same pool. So these are exactly running and taking up the same drive. So you have just two different methodologies of presenting off of the same hardware, same drive, same everything. So yeah, it's kind of interesting though that overall, iSCSI just handles it better. We have higher IOPS out of iSCSI. We have higher rate. Your throughput is much higher on here. It's just and in every way quite a bit faster once you scale up and once you have all of these extras going on. So iSCSI really is a better way to present it there, to get the both synchronized writes and have it done there. Now, this could be another way to twist it would be if we had an NVMe, or if you look at some of the really high-end systems like TrueNAS boxes, and they use like the Zeus RAM for the ZIL, some of the really like $1,000 specialized ZIL boxes. Well, that's a whole nother topic, because now you can get even better performance out of your NFS connections than you can out of your iSCSI, because your intent log became is that much faster. And then you can also say, well, what if you built this all on NVMEs as opposed to SSDs, which, you know, creates a whole nother level, because suddenly the seek is way faster, and so is the overall ability for those drives to write. So I do know that there's some new servers coming out that have all NVMEs. SSD caching SATA with HD. So no, the SSD, it's all SSDs. Everything here is SSD. All of them are. They're there's no, well, they're spinning drives in the system, but they're not part of this project at all. So everything you see here, matter of fact, can we list the smart status? I think that would be pools. Oh, disk right here. I had to do it from the command line. Hold on, what's the actual, is it DA0? ADA0. Actually, we'll do it in this window. EXIT. /dev. These are SanDisk plus 240 gigs, so nothing special here. They're not the fastest drives at all. So just these are all solid states. This is a FreeNAS Mini XL Plus. Yeah, they're all SSDs and they're in a RAID. So if you zpool RAID Z configuration. Matter of fact, right here, RAID Z, RAID Z1. That's these ones right here. So there you go. So SSDs, RAID Z2, and these are SSDs as well. So each one of these is SSD. Yep, RAID Z1. Just a basic setup. Kind of get you the idea, though, of how it works. Let's see where this is at. Pull these back up. But consistently, you can see we're just getting more speed out of iSCSI under really intense situations. So it sounded like at the beginning of the video that NFS was going to be faster when you when you dig really deep into actual performance, when you're running a whole bunch of VMs. This is not even a bunch, this is 4. But when you scale it out, you really have to consider just how fast you want it to go and how it handles all of that. And yeah, when all said and done here, this was able to average 223. This was only averaging 168. And that's these particular VMs competing against all the other VMs at the same time that are running. Kind of gets you a better idea of the perspective and why storage planning is something you have to spend a lot of time thinking about. Also, I'll note when we do something on here, and we'll just run this real quick. 1, 1, 1, no. Notice that when this writes, that you end up with a lot going on in the ZIL here. So it's 267 megs that needs to be committed, et cetera, et cetera. But when we run the same thing in here, much less committing going on. Matter of fact, the cache occasionally kicks in. So here's all the writes going on, but it doesn't really need the intention log because the ZVal is being presented and it's a block storage device. And because all the VMs have settled down, we're back up to that nice fast 416 that we got before. Let's see. Oh, good eating from Switzerland. Awesome. Let's see, what else can we talk about related to this? So this is I love seeing all these tests and the IOPS and things like that. And it's kind of cool being able to see how this works. Oh, if you want to see something ridiculous though, it's funny because this is a problem with doing tests So we're going to do one read performance testing. I wonder how fast this can read. It must be super fast, right? Look, we had a couple things pulling out of cache here. A little bit of we got some numbers. The read on this is actually going to be funny. So we're at like, what do we hear? 3,136 megs per second when you read, which I don't think is real, by the way. I don't think it's actually reading that fast, but a lot of things do get cached. So benchmarks have a hard time inside of a VM understanding speed. And they both get about the same things. You're actually reading from what the VM goes, hey, I see all these requests for the same file. And even though it's trying to exhaust the cache, it's trying to exhaust it, assuming Phoronix is assuming not working on a virtual machine with the IO zone. It's assuming working on bare metal. Therefore, bare metal doesn't have that cache. So for a home lab server, what do you think is better? FreeNAS on bare metal? And do you virtualize or do you use VMware to host FreeNAS pass through the HP directly? So I'm partial to XCP-ng over VMware, but take that for what it's will. You can pass through, and this is true for XCP-ng. XCP-ng will also allow you to pass through hard drives. So if you are limited in budget and you can't just build a separate FreeNAS machine because you want it to be virtualized, yeah, absolutely. If you go, I only have room for one box. This is what my budget will allow. This is what I have room for my lab, and I want to do experimenting on this. I want to be able to learn FreeNAS and another tool. Virtualize it. You know, if it's one of those things, like it's all about learning and learning. I have a lab, despite working in the industry. I can't always test or learn on client's hardware. So sometimes I spec out things, or even before they get deployed, they come here to my office to be built, tested, evaluated, and then deployed. So yeah, why fix extensions faster? Yes, if you have a significant other who is concerned about your budget, it is important that you not fill the room up with too many machines. This may be, if you share and cohabitate with another human, there is a concern they may have if there is too many machines in one room. The heat concern, the electrical concern, the can we eat dinner tonight concerned because we have spent all of our money on hard drives. So I'm all for it. I like virtualization because it requires less physical hardware, but yeah. So what size should a Zlog drive be? That's a very interesting question. And by the way, please note that on here, I'm only, when I do a write test, and we're going to go ahead and do another one. So we'll go 2, 2, 1. I want you to see something here. There's a mistake that people think you need a larger one. You need basically one that's very write durable. Please note, this has got 400 gigs free and never uses more than 300 megs of it. The ZIL will only contain, and there's a math equation. If you look up for ZIL sizing on FreeNAS, there's an article that gives you the formula. The formula is as much data as you can pass over like 5 seconds of time. It's a time, but it's never more than like a gig or two. So it's never that much. You can get away with like a 120 gig drive all day long. You can get really cheap stuff. So what is the dashboard for IOPS read now? So 7,000 right now based on what we got going on. We need to do something more intense. So we need it to, let's have Windows do something. What can Windows do that would be intensive? I know, let's do this. Let's just break this machine because I'm gonna have to go pretty soon. Let's say 1 gig files, run all tests. So 2 passes of 1 gig file on this. That one's going to start writing. So there's the SCSI one. Let's go over to the NFS. We'll do the same thing. 2 passes, 1 gig, all. And then, while we're at it, we'll just go 4, 5, and why not 3? There we go. Let's run all the tests. Let's see if we can break the FreeNAS machine. So we're going to try and corrupt something because it's all a lab and we want to know what happens. How do you recover from it? I've just gone and unplugged this while it's running. So we're basically maxing this out to the absolute max possible because every one of these is doing something. They're all going to choke horribly. Actually, let's do this here. So console. Now we can look at each of them like this. So this is it. This is rating. This is rating. This is pretty intense right here. Yeah, an NVMe one we go. So yeah, put the lab at 100%. That's basically what we're doing right here. We're not maxing out the CPUs. There's that. There's that. And by the way, this is another reason I love the way Zen Orchestra works. I can just open up all these different windows and be able to manage different aspects of the server. From a host standpoint, we can look at it here. We can see what's going on from a host standpoint. Let's look at the, what do we got here? Host, pools, storages are the one that's being intense right now. We can actually expand them all out like this to see what they're doing. So, yep, lots of read, write, disk information going on here for all these Windows machines. And then we have this and this, so we can watch it really get cranked up here. So, once again, all this intense writing going on, we're seeing a 13 millisecond latency over here on the same drives running NFS versus right here, 6 millisecond latency. That's a big difference. We're at 50% I/O wait time here. We're hitting the 43% over here. So I/O wait time definitely catching up here. Do you have any problem with XCP hardware compatibility? Not really. The challenge is really making sure, like if you look at the compatibility list for Citrix, it's going to match. It's running a standard Linux kernel, so there's not anything too weird about it. But you are seeing, oh, by the way, our IOPS over here, if you notice, we're 17K over here. While in, let's see, at the same time, so this is at 520, 528 over here. So I'm impressed with how well the FreeNAS box is handling this. It's actually all this intense reading and writing, and it's still working. Anyways, the compatibility, I know there's some workarounds. Like if you look up how to work it with Ryzen, there's some compatibility issues with Ryzen because they're not running a bleeding edge kernel. So there's some issues, but they're getting worked out quickly. And there's some ways to make it work on, for example, Ryzen hardware. And I'd bring that up because a lot of people have asked me about running in Ryzen because of all the processors and everything else. So yeah, lots of reading and writing going on here. And nothing's crashing, by the way. That's the other thing. We have clients running this system with really intense read and write workloads because they're large warehousing companies and things like that. So, yeah, you can try stress more, reach 20K. Yeah, so that's a good point. It works with CentOS 7, so yes, it should work with most things that work with CentOS 7. They have, if you look, they have exactly which kernel they're using, which I probably could even answer that question here. It's using kernel 4.19. So there's the kernel version that we're using. By the way, it's kind of cool. You can run HTOP in here and see some of the stuff that's going on. There's a lot of, I like because it's all Linux based. You can see a lot of the back end inside of this is in what they refer to as DOM0. But it only shows part of the processors because DOM0 only needs part of them. The rest of them are exposed elsewhere. Will it work with CS63? I don't know. What is CS63? Yeah, if you like Proxmox, that's Proxmox is fine too. Proxmox doesn't have a few features that this has, the way this does the Delta backups and things like that. This to me works a little better, but a lot of people, I have a friend who loves Proxmox, uses it for what he does. It works wonderful. It's not a bad system at all. To me, I like this better. I like the way it works. I like the way I can pass the VMs. There's certain, I can't remember what it was, and me and Jay did some details on it. There's a few things that Proxmox is still not caught up on that you can do in both VMware and XCP-ng. VMware and XCP-ng are like in parity with each other in terms of all the features you get, but you know, you just have to be able to, it has to fit your use case. That's the whole thing. Will not run Crisis, man. You just don't have, we don't have enough servers to throw at Crisis. I know that's always the big question. So back over here. Oh, look, these are still, these retests got really bad really quick. We start out good, but when you have everything reading and writing to the same virtualized hard drives all the time. Oh, yeah, the backup feature is amazing in this. When you, being able to do the backups. As a matter of fact, let me pull up my production machine here. We go to a production one. So, for example, we do continuous replication. I mean, being able to replicate our entire invoicing system and keeping series of replications, it started at 520.03, it ended at 520 in 15 seconds. So it took 12 seconds to replicate all the changes that happened between 1 hour, because this is set up to be hourly replication. So it's really impressive how you can do these Delta backups and then quickly spawn from them. Matter of fact, that's actually one of the things it's really handy. So let's say we wanted to spawn more machines now. So here's our FreeNAS Mini XL Plus disk. And what I want to do is, let's see, we can, well, a couple things. One, we can just download this VDI. That's definitely an option. We can live migrate it. Of course, we have those options. But we can also build a copy of it. And we're just going to do a fast clone. Debian SCSI fast clone, because this will, oh, I need to stop the VM state. Hold on. Stop. Yes. So we go over here to snapshots. Or we don't need to, we can just do it. We'll just do a fast clone. There's one. There's another one. And another. And another. And there's other ways to do this, by the way. But now we're going to go here and we're going to type the word. See. Here's all those clones I made real quick. Fire away. Are you sure you want to start 5 VMs? Of course I am. The dynamicness of being able to do this, and I know there's ways to do this in Proxmox. There's even ways to do this from completely scripted from the command line. You can clone the VMs, you can manipulate them, and do all these fun Delta backup features. This should push the IOPS of the SCSI one quite a bit. We just booted a bunch of VMs at once. Yeah. Yeah, there's no catches on the licensing. It's 100% open source. There's no this, that, or the other. It's all open source, all free licensing. There's nothing about it that's no gotchas. That's probably a good way to put it. And with some of the projects they're doing, I've talked about this before. One of the projects they have is between physically separate servers. They can be one at home and one elsewhere. You can build IPsec GRE tunnels between them. So two separate XCP-NG servers can have a tunnel between them without you setting up a specialized VPN. It will create a shared network pool. And I'm going to be doing some lab videos that I'm working on. And this is one of the reasons I like for a lab. The way you can define networking on the fly and create a series of labs, a series of hidden networks, but they actually can be shared between multiple instances of XCP-NG. So you can have it over here. You can build your firewall on one of them and then pass a virtualized network adapter on the other side. So it's kind of cool how it works. XCP-NG backup solutions, that's all built in. That's the beauty of it. Like the whole backups are right here. So this is where I can do any of the backups for any of the things that I need a backup for. Matter of fact, they're all completely scheduled. The types, you can do however you want to do it. Matter of fact, we can even kick off a backup while these are running. Actually, where's this one live? We can make a new backup because I think all these are quiet right now. All these are off because they're not part of what we're running on. But here's all those ones I cloned. So There's the NFS stuff. That's probably also running. Wow, 16,000 IOPS. Wow, this is running over here. So we have pushed this to the limit. Let's see what net data says. It says we're beating up the server pretty good. And ZFS can carry on. Can you configure a network with two? Yes, you can do network bonding. You can bond a bunch of them together. You can have the particular setup that I'm using has individual 10 gig ports, 2 individual 10 gig ports. But yeah, you can actually bond them for a 20 gig. So as someone pointed out, you're running into limitations of the drives or of the network. I'm like, yeah, you could bond them together so you could then get more speed again. So what about coherent backup of clustered VMs? You could do that. You can. That's not, you can back up however you want. There's a lot of different options on the backup. Matter of fact, they're adding this really interesting proxy backup system for remote. It's kind of a neat idea. I think it's in beta right now, but it's going to be a really cool add-on feature for people who manage these in data centers, where you can use the Zen Orchestra, but Zen Orchestra, instead of facilitating the backup, you'll be able to do that. So any projects on cold backups like air gap? I've talked about it before. I do that myself. You create immutable backups. Matter of fact, that's one of the reasons I did that video the other day on those little SSDs. Those are where I store them at, and then I take them physically off site, so they're air gapped. Oh yeah. I don't know how to say the word. I'm gonna look it up while we're here. Pronounce. How do you say this word? Pronunciation. Quis? I don't know how to pronounce it. That was not helpful. How to pronounce? Yes, it supports it. Quiescing. Yes, it supports quiescing. So if we type in XCP NG there's a whole write-up on how it works. Where's it at? I talk about it in one of the recovering. There we go. It's a feature though. It's completely is supported in the system. So that's the question. Yeah, no pronounce. But it is a feature, so you can get these type of snapshots within the system. So it's been on there since the we added support for auto quiz snapshots in November. So it's been in here for a while. This is, how old is this blog post? 2015. So it's been around for 4 years. So yes, it supports it 4 years ago. But it's the Delta backups is really cool because it does that combined with the Delta. So it actually has another feature that's kind of interesting. So let's go over here to the backup, restore. Let's break this down. So let's look at this Windows 10 lab. And tell me what you guys think of this. Yes, you can do this. You can do Delta synced backups, then only not restore the VM, restore a file from inside the VM from one of the slices that's from in there. This is, like I said, they've really detailed this out. So if you go, man, that person did something really bad, but I need this, then you can go back and go to do file level restore from inside of, and the file level backup, by the way, look at the backup that produced this. So here's the Windows 10 that I was able to pull files out of, right? Look at this is the backup program that produced it, was right here. So if we edit this, please note, this is just a Delta backup of the Windows 10 lab. That's it. But I can pull files out. I can restore the whole image, or I can pull a file out of it. That's how that works. So it's pretty, it's really kind of cool, the fact that they allow you to do full image backups, full image restores, and find a file within that image and pull it out. That's the impressive set of features that are around here, especially if you have you keep old offline backups because you have a lot of them. And like you said, if you have it air gapped and man, the backup ran a few times, being able to go backwards several files and not have to go through a full restore to extract it, being able to pull just one single file out is, to me, pretty cool. And of course, these, like I said, they're all disabled, which that's an automated thing, but you can click enable and turn them on so they completely automate your backup scripting on there. And it does support HA and everything else if you have a big enough cluster, et cetera, et cetera. So those other features are supported. So I think I'm running down to the end of the show here. I was about to migrate Proxmox 6, upgrade. Proxmox does a lot of cool stuff. So replication backup on 2 FreeNAS boxes. So the data, just so you know, you can land it wherever you want. They're called remotes, and I have this covered in there. So you pick where you want to land it. An SMB share, a local spot, an NFS share. These are actually set up as NFS on another box completely. So these are on my storage network, which you don't see much of, but 1010 is storage network. This has a 10 gig connection to the .10 network, which is just dedicated for storage. So you can store them wherever you want. They're not stored on another XCP-NG server. They're stored on another NFS share that is done there. It doesn't support, well, it doesn't natively, but you can make it support whatever you want, because what you do is you choose local, you give it the path. That path can be whatever you've built into Xen Orchestra. So you can really store it on whatever you want with very little challenge. This way is my preferred way to do it, and it's just an NFS share, which is perfectly fine. So you just configure it to land wherever you want. So if you have some, let's say, a FreeNAS box in the other room, or even as long as it can get to it remotely, if you have enough speed, you can back up to said FreeNAS box, and then you have that file. Then what I do with those files that are on the FreeNAS box is I take them and put them somewhere. By the way, the structure on that, let's actually talk about that because it's a relative thing. So if we, Dozer, oh, it's not on Dozer, hold on. It's on this box. Xen storage, Xen lab backups, XO. So it gives all the files their name, but watch, when you go in any one of these, whoops, crap, typo today. They're all in JSON, so you can actually pull the JSON file out and actually see what this is. It doesn't take long to figure out what this is, to follow through and see what's inside of it, figure out all the features and reverse engineer it if you needed to. And the actual file is in here in Vitis. So if we go Vitis, and there's the actual VHD file. So if you needed to do it without using Xen Orchestra, that you can actually get the VHD file and pull it back. So there is that. So the last place I'll show you, that's a Delta backup because it needs to keep them in VHD because it has to do differentials. But if you aren't doing Delta, if you're doing full backups, so you're doing Xen server VM backups, that's going to be different. So XO one. So there's your standard XVA file that you can just import. That's a standard virtualization format. So now you can actually just grab this XVA file that we dropped on here and import it into a machine knowing nothing else. And now we have the XVA file that has all the settings in it. So can it pull SQL data from a database in a Windows VM? It pulls it at the file level, so it's going to be whatever file you're looking for. So, yeah, and all this, yeah, so you could pull data out of it however you want, as long as you know what the file is. Can it do PowerShell? No, it's not PowerShell at all. All of this is going to be It's all bash, so none of this is PowerShell. But it kind of gives you a good idea of how this works. And of course, here's all those. Look at all these VMs running on here. Woo! Lots of stuff going on. It auto-assigned them all the IP addresses. One of the other things that's nice too, we built these all and we put them all under the .3 network. But if I want to swap what network they're in, we have a whole network called Pwnage. So if I wanted to throw some stuff for Xavier, this is where we play on our hacking stuff. You can dynamically. So now it's in the Pwnage network, which is 10, 13, 37, 103. So this will allow you to quickly move. This is one of the things I like about it. So we can just swap networks all we want. Like pull down here. Now it's back over here. Whoops. Got to go to the console. That's where I was. So as in 103, we swapped the network. Now we're back into .3 network. FreeNAS stable. Yeah, I'm using the latest version of FreeNAS. Nope, my network is only IPv4, no IPv6. But yeah, it just works really nice. Oh, they added this feature, which is kind of cool. You can SSH right into a server. So all it does is open up whatever you have programmed to launch as SSH. I thought that was kind of novel that they added that. It also knows what IP address is assigned to this. So when we swap the networks around, it'll update what IP it's assigned to. So it's here. Let's put it over on the Pwnage network. Plus, you have some of these options here. If you wanted to run virtualization inside of virtualization, you can do nested virtualization. You can decide if it's on an HA server. If it is, GPUs, it does support some of the higher end GPUs, NIC type, video RAM assigned to it. You can do weighted limits. It knows what version of guest tools are in there. You can assign ACLs to it if you wanted to for the management so other people can manage the whole interface. Let's see, console. It takes a second before it's going to realize the network interface. There it is. That updated. It does support the virtual GPUs. You can do pass-through, but it actually, if you have a supported card, like the high-end Tesla cards, those work in here as well. So actually, if you look for... there we go. These are all the ones that support, like the Tesla M10 supports vGPU, the M60, P100, everything else. So these are all there. But that's it. I got to run. Thank you for joining the live stream, talking about stuff and helping me nerd out. I'll make a more concise video about this to talk about how this all works. But you can see this is obviously a lot of fun, being able to build up all these VMs and get it all reading and writing and all this fun stuff. So I had fun. Hopefully you had fun. Maybe you learned something. Maybe you didn't. Thank you for those of you that donated money. I will be spending that money on, I don't know, something. So, but this is a fun topic. I will say the next topic that's going to be coming here, I'll show you guys, 16.69.14. This is going to be another video topic. It's in the works. Let me see if it's actually done, because I want to reboot it if it's not. Yay. But this is Kali running on a Pi. So this is Kali Linux on a Pi 4. So this is all going to get set up pretty soon too. So next video, box with 100K IOPS with all. Dude, I want to build a full array NVMe system. So that's definitely on my list. We're going to reboot this Kali box. But that's coming up, a Kali on Pi and a bunch of other fun stuff. So that's all coming up. I'm going to shut all these things down. Actually, I should shut all this down. This is wasting electricity now, right? We'll shut down a massive amount of VMs and we'll purge them from existence. This is why I have a lab. So we'll select, but unselect. Don't shut down the lab server itself. So stop all you crazy VMs. There, you can send a stop command to all the VMs at once, just like that. And they're all gonna shut down. Look at that. Kind of load did that put on things, closing them down? Probably not as much. Whoops. There they are. Yeah, it doesn't take much load to shut them all down. Not like it does to boot them all up. Calm down, lab. You know, the server is in the back for a reason, because once you start doing all this, the fans spin up and it gets noisy, and I want to record a video. That's why we decided not to mount it in the lab. We stuck this, the demo server is completely sitting in the rack. It's the only logical place where it just got too loud. I realized it was a challenge making the videos based on that. And this is the R720 provided by our friends over at TechSupply Direct. This was XCP-NG 8.0. Yeah, it says right here, Dell PowerEdge R720, 32 processors of power. Look at, oh, for those of you wondering what the CPUs were doing, it was doing that. And look what happens. Ooh, all the memory usage. What does the last 2 hours look like? Yeah, here's where Tom started playing with these stuff. Yeah, plug failed to start. Yeah, I did a thing. I broke it the other day. I had to reboot stuff. But it works well. Enough of this fun stuff today. Oh, and someone mentioned multipathing, in case you're wondering. Yes, you can do multipathing with iSCSI, et cetera, et cetera. I'm not digging into that today, but yes, that's another feature. It is supported inside of this. So that was it. Thank you very much for joining me. So I'm going to go. It's my daughter's birthday, so she's going to go out to eat. That's the next plan. I got some weird emails I got to answer now. All right, thanks. Later.